live stream. I believe we're at number 86, and very excited about that. Literally just finished another one about an hour ago. And so kind of changing gears. Earlier today, we were talking about data ops, going to be talking about something a little bit different now. One thing I do want to mention before we get started is, well, actually a couple of things is that, and particularly since our speaker today is joining us from the UK, next week, you got Kubernetes Community Days UK. Check that out. It's a free event. You're going to have lots of good speakers from lots of different companies addressing tons of really relevant topics. So definitely check that out. Also, just before we start, want to let everybody know, KubeCon is coming up, and we have a co-located event that will be on October 12th. You are all warmly and cordially invited. I'll leave the link for it here. Schedule for that should be coming out quite soon. We're going through the CFPs to get all the finalists together, start building out our schedule. But there will be lots of information coming about that next week. In the meantime, you can just register already, so it's already on the calendar. That being said, today I'm joined by Dean Lewis. Dean, how are you?
Hello, everyone. Yeah, great. Thank you very much. It's been a busy day today. We've been running some automation workshops for some of our customers here at VMware where I work. I'm really excited to present at the Data on Kubernetes community. For anyone that's listening now, I'm a massive advocate of community-based programs like this. I actually reached out to Bart about 2 months ago.
Correct.
And said, hey, Bart, I've seen some of your sessions that you've hosted. I think I've got a session that I'd like to show too. Can we have a chat? And now here I am.
Here we are. And you have an interesting job title, because when folks go to your LinkedIn, they see Office of the CTO. What does that mean? What's your day-to-day look like?
Yeah, so actually my actual employed role at VMware is I'm a cloud solution architect focusing on our cloud management products. But I actually am part of an internal program, which is a field-based ambassador for our Office of the CTO as well. So obviously, at the end of the day, we're a software company. We produce products for our customers. And this is a way to make sure that our R&D are as linked intrinsically with our customers as possible. And we do that through our field-based teams. So I'm a member of the field. I applied internally for this thing. I get to speak to really cool R&D people, engineers, see what's new coming in the future. But at the same time as well, I've spent many years being a customer. So I have, been there, I've installed it, I've done that, I felt the frustration of support teams, to vendors when you ring up. So I find personally myself that I can still quite a lot of the time put my customer hat on, and I enjoy representing the customer back to my employer and saying, hey, this is what's right for the customer, this is where we should be going. Because let's be honest, if we're not doing the right thing by the customer, we're not going to exist for much longer. Absolutely correct. I think it's a great point. And I don't think it's anything we can ever repeat too much or keep it in mind too often. And in your experience, because I think a lot of vendors struggle with this, you ask them about a buyer persona and they have a certain idea, but maybe they're really not interacting with end users. What are the right questions or right things to keep in mind for vendors that maybe are struggling with that? Maybe startups, that are like, we got this great idea, but we just can't get anyone to, to give us feedback on it. In your experience, what's the best way to approach that? So it sounds almost like a cliche, especially if you read management books and things like that, or if you kind of done lots of TED Talks. So, one of the most famous people in the world is Simon Sinek, and he did a session on let's start with why. And I think the book is either called that or it's called just why. Find your why, or and that's what you have to do. And it's really, really true. So at the end of the day, we all love working with technology, and we're here today to talk about Kubernetes. Let's be honest, Kubernetes can be really cool, also very frustrating when you're learning it. But there's no value to a business going putting Kubernetes in. You have to enhance the business. You have to do something with it that is a benefit. That benefit is most certainly tied to an end user, whether that end user is internal, maybe the HR department, might be the sales department, or the customer that you're selling to. So you need to drive more revenue. You want them to buy more services from you. Why do you, as a customer, choose to use Amazon all of the time versus another platform? Typically, it's because ease of use, breadth of products. They've got a platform that supports all of that. So if you're a customer implementing technology, get back to the reasons why and what them outcomes should be to improve your customer's life. You've asked a really interesting one there, though, of saying, well, what about if it's a startup? What about if we've got a product we want to take to market? There's been many great ideas out there that have failed, unfortunately. And the reason for that is because it's a solution looking for a problem. If you don't understand the problem that you're trying to fix out there, no one's going to buy it. So you need to get to the why that solution, why the customer's going to struggle, and why they're going to invest their time, money, and commitment into using your product to remediate that problem, to get rid of it.
Yeah, I think that's a great point. And as you use the word struggle, I frequently try to look at it as suffering. What is this customer suffering from? You're suffering from something, your willingness to pay for a solution is obviously going to increase. So I think that's a really, really good point, to be in tune with really what's going on and not forcing solutions on companies. Like you said, like you may have a solution, but perhaps there's not a problem. Very, very good. That being said, what are we going to hear about today? Design patterns and benchmarking. What's up with that?
Yeah, so I've been learning Kubernetes now for about just under 18 months. It all started because a customer came to me and said, "Hey, Dean, we're trying to automate the deployment of this platform. We're struggling." And I asked that question. That their question was around how do I deploy a certain virtual machine that I'm struggling with in my environment? And I asked that question: what is it you're trying to do? Why are you trying to do that? And they mentioned it was a Kubernetes environment. And it's like, oh, interesting. Well, talk to me more about that. Why are you trying to deploy it in this particular way? What are you trying to achieve? So as I go along my journey, I've been really interested in all of the different areas, but my background has been virtualization administration for many years, design, architecture, deployment. And quite a while ago, I was having a conversation with someone who presented on this community a couple of weeks ago, Michael Cade, who works.
Yes.
Yeah. And we were chatting about benchmarking. So, okay, this is really great. We're doing lots of things in like these test labs, or we're doing it in EKS, for example, where performance should be really great. How do we actually benchmark that? When I deploy a virtual machine or I get a set of requirements, I know how to build that up. So I started to look into, well, how do we do this in the Kubernetes world? What's different? What do we need to think about? And then what are the tools available to help us get those data that we use to typically understand what performance is needed from my platform, or what performance my platform offers? So today is kind of my thoughts, my ramblings, my learning so far, because this isn't an end thing, this is evolving. And it's the basics of performance testing your Kubernetes platforms and workloads. And we're just going to really talk around some of the considerations that I've come up with and some of the tools that are out there to help you. And maybe if there's people listening today in the community that can also add some context flavor, what they do today, what tools they use, that'd be fantastic as well, because I'm still learning.
I think that's great. I think, as you said as well, is that I think everybody's learning with Kubernetes. Like, I don't think there's anyone who's like, you know what, I've got enough. I think I'm done. I don't need to learn anymore. But I think it's really nice about learning in public, getting these questions out in the open, because if you have those questions, for sure, somebody else is going to encounter them as well. So I think it's a great way to look at it in terms of the things that you found that have worked. And so if you want to share your screen, we can take a look and jump right in. Yeah,
perfect. So I have a handful of slides that we're going to go through today. And then once we get to the end of the slides, just gets a little bit easier, I'm going to share a section of my screen, and then we'll use some of these open source tools in one of my environments as well. And we'll kind of just have a chat about kind of how some of them work. And yeah, we'll take it from there.
Perfect.
So Bart did a great job at asking me who I was and just a little bit about my background. But so my name's Dean Lewis. I'm a cloud solution architect here. That's the dot I will grab. That's because I live on my own and I just need to grab a package. Really sorry about that. That's typical.
That's okay. Not a problem. This is the first time we're taking a dog break, but hopefully not the last, because we have to remember in 2021, these interesting times we're going through, it's a great time to be more human. We all get to see different things in each other's houses. We have different things going on. We have different time zones. We have all these different things. And these are the things that we can celebrate. That we have people from all over the different parts of the world that have cats, that have dogs, that have children, that have neighbors. This allows us to have a different kind of experience that previously we would not have had. While the pandemic brings many challenges, it also brings opportunities. And this is the first time that we've had a dog on. So thank you very much for that, Dean. Much appreciated.
I'll tell you what we'll do. We'll very quickly, everyone can say hi to
Alfie. That even better.
So this is Alfie. Alfie is a pedigree Shih Tzu who seems to be 10 times the size of his cohorts. But yeah, if I didn't go
that's the biggest Shih Tzu I've ever seen.
But if I didn't go and answer the door, unfortunately, we'd be hearing him barking constantly in the background. So as I was saying, my name's Dean Lewis. I'm a cloud solution architect here at VMware. I do also represent the Office of the CTO. I blog at theeducate.co.uk, and I can also be found on Twitter at Saint DLE as well, if you want to hit me up after this session. Thank you for bearing with me there.
And you're a diver?
Yes. So when the world is not quite suffering a pandemic, I have been diving for the last couple of years as well. One of the most amazing things I've ever done. It's just, I've done all sorts of extreme sports over the years, and diving really kind of stands out there as one of my favorite things.
Nice. Very, very good. Any places in particular that you would recommend? Like, if you have to dive one place, I would definitely recommend going here.
So if I tell you this, the problem is it become busy, and then like
okay, that's fine. We keep it secret.
Obviously Australia is the nirvana for the Great Barrier Reef to go and dive at. I've not personally got there yet. However, there are two other places in the world that really stand out. So Japan is fantastic for diving. It's quite expensive to get across to Japan, but they have some great diving out there, I believe. So that's on my list next. There's also Mexico as well. So if you are on the east coast of Mexico, they have some fantastic reefs there. They have the second largest reef in the world to the Great Barrier Reef. And it's also a lot cheaper to go there. So really head out there, soak up the sun, soak up the fantastic food, go diving.
Yes. Perfect plan. I'm in.
So for today's agenda, we're going to talk about our infrastructure. We're going to talk about our platform, some design decisions, some native storage. Obviously, I work at VMware, so we are really going to be basing this around running Kubernetes on virtualization. There is some great papers out there nowadays done by a number of different firms that talk about bare metal Kubernetes versus Kubernetes in virtualization. It really depends on your needs. Some of these design decisions are going to cross over into the physical bare metal world. Some of them won't. But what I'm typically seeing out in the field is a lot of my customers are going to virtualization deployments over bare metal. Typically, the customers who want to go bare metal Kubernetes because they have maybe particular hardware characteristics that they need to pass through to their pods and containers. So certain ASICs, graphics cards, and so forth. Some of those things nowadays you can also actually pass through when it's in a virtualization platform as well. Talk a little bit about networking. We're going to talk about resource management, especially in a virtualization platform. Talk about scaling, because there's two ways to scale an environment. They've got the platform itself, you've got your applications. Talk about those benchmark tools. So how we're actually going to get that data to use in our environment. And then finally, we're going to hopefully have some time to go through a little bit of a demo as well. Please do ask your questions in the chat, and Bart will stop me as I go on to ask those questions as well.
That is absolutely correct.
So first and foremost, let's start off with our infrastructure. So as mentioned, we're kind of really going to focus on virtualization world. So if it's just virtual machines, right, we're going to deploy some virtual machines, install an operating system, configure Kubernetes. We might use an opinion Kubernetes deployment, whether that's VMware Tanzu or whether that's maybe OpenShift. So that comes pre-packaged for you, but it's still virtual machines. What's the actual platform you're running on? So what actually makes up that hardware? What makes up that virtualization cluster? What storage is it backed with? What's the characteristics of the host that you're using, for example? And how are you going to surface those resources to the virtual machines? It's the first question. So is this a shared platform? Are you running it side by side with normal virtual machines that run your everyday operations? Or is this a dedicated cluster only going to be used for the Kubernetes virtual machines you run on top of it? And again, do you have any particular hardware requirements, such as maybe graphics cards that you want to pass through into the compute plane nodes of Kubernetes itself? Those are kind of really the first things that you need to think about from that point of view. And then if you are doing any of those things, does your virtualization platform support you doing that? Do you have the right licensing in place? And is it configured at the right with the right settings as well? And then finally, is it at the right version support as well? It could be your platform supports the pass-through of hardware devices, but maybe not into the versions of guest OSs that you're running at that point in time. And although these kind of seem maybe like some fundamental things that we've not even, we're not talking about performance here, they fundamentally will affect your journey when using your Kubernetes platforms as you go forward and mature your platform. So we need to think about the compute level. So are we using anything like resource pools to ensure a quality of service of those resources that have been passed up from a CPU or a memory point of view? Have you configured something like limits, or have limits been accidentally configured either at a virtual machine or resource pool level? Those can have a detrimental effect to performance straight away. Typically, we see customers implementing them in lab environments, for example, or when testing or trying to troubleshoot an application. Realistically, in the virtualization community, it's typically understood that limits should be used as an absolute last resort, because the problems that they cause and the misunderstanding. Resource pools are useful and are used more frequently than limits. But again, you need to understand the hierarchy at which you apply those resource pools and the settings that you put in place. So if you do have a separate lab environment, please test this before you go ahead in production. And then finally, in vSphere, we have this concept to be able to move virtual machines around the platform to the different underlying hypervisor nodes. We do that dynamically for you, which is fantastic. But what's the impact of that? Do you need to set rules in place to keep these control plane nodes away from each other so that they don't run on the same host? This helps if there is a host failure in the platform. Your virtualization platform should be able to continue running and self-remediate when that host is available. The virtual machines will be moved around the system as it can determine on the available resources. But your Kubernetes platform won't survive if you've got a 3-node cluster, for example, and all 3 nodes run on a single host and that host goes offline. So thinking about the settings that you can put in place to control those types of failures. The storage. So again, coming back to this idea of a shared platform, do you have dedicated storage for your Kubernetes environment? Are you maybe not even using the underlying virtualization storage, but going to bring separate storage, maybe using NFS into the system, which is going to use the networking of the platform into your pods? And then finally, as we think about networking, do we need to think about quality of service? So VMware and other hypervisors out there support quality of service from the networking layer to the virtualization layer, and they can pass that up to the virtual machines. But in a Kubernetes environment, you're running a platform within inside a platform. So does your Kubernetes guest OSs and does the Kubernetes deployment itself and the CNI understand that QoS that's being put in place? Or is it expecting that everything on the network is open and is best effort, for example? So let's dig deeper into a few of these options. So with cloud native storage, although we're going to talk about VMware's vSphere today, we're going to really talk about the CSIs that are available. So previously we had in-tree drivers. These came shipped with the version of Kubernetes that you deploy. And if there was a bug, a problem, or an enhancement, you wouldn't receive that until you upgraded to a newer version of Kubernetes. Now, that's been decoupled. We have out-of-tree drivers and out-of-tree deployments. This is implemented using a CSI. When your application is deployed, it requests from the CSI, or the storage class that backs it rather, to create the storage and bound it to the application through a persistent volume claim. When it does that, this storage class, depending on the drivers that are in place, are going to speak to some sort of control plane to ensure that that storage is available on a dynamic basis. In VMware, that's going to speak to a CNS control plane that speaks to our management vCenter service. And that then goes off and creates the right either block or file-based storage for us to pass back through to our Kubernetes applications. This is AWS or Azure. This CNS control plane is going to speak to the APIs of AWS or Azure, or a very similar concept for any other platform there as well.
Real quick question, Dean, because you said you've been working with Kubernetes for the last 18 months.
Yeah.
When you got started out with this, what was the most challenging part for you, particularly as it relates to storage? And and also on the customer facing side, what seem to be some of the major challenges that they seem to have when getting onboarded with this?
So one of the things that I like about kind of our cloud native storage implementation is you've got a VMware platform, that's your hypervisor platform, and the storage going to be attached with that, especially if it's a shared platform. So you can now surface that underlying storage into your Kubernetes environment and still, rather than bringing a separate piece of storage and having to stitch it all together. One of the challenges that I find with customers is understanding what is the best storage option out there. So I've gone and spoke to customers who've been on their Kubernetes journey for 5 years or so, and they started off when storage was kind of really a bit of a finicky thing. There weren't really any provisioners out there. The drivers were really basic. And basically, they design applications and they would do NFS mount points inside the container to an NFS protocol-based SAN or NAS box, for example. And then, the customers there are struggling to, okay, how do I move that persistent data into a more enterprise-based storage? In the Kubernetes world, that's been made slightly easier in the fact that the CSI definitions can support migration from an in-tree provisioned volume to a CSI provisioned volume, but that's down to the CSI provider to implement those features. So unfortunately, not all storage implementations, whether it's the underlying control planes and CSIs, or whether it's actually, the physical storage arrays, are the same. So it's really key to understand, if you're going to use existing storage, what's available today, what's its performance profile, especially if you're going to share it. If you already got, some database servers running on there that are absolutely hammering it from an IOPS point of view, is your Kubernetes environment even going to get enough storage performance there? And we're actually going to look at how we can do some storage testing from that point of view, from a speed and an IOPS point of view inside your containers. And then going forward, does it actually support the connectivity methods that you need as well?
Great stuff. Very, very good. Thank you.
So the next piece, as we kind of really think about the underlying platform then, is around networking, and storage could still come into that as well, depending on how you're surfacing that storage. Are you using the NFS protocol? Are you doing something with iSCSI, for example, maybe? So the first thing we need to think about is, what network plugin are we using? Again, in the world of Kubernetes, the container network interfaces, as they're called, they are not the same. We have some fantastic out-of-the-box options that are typically used in smaller environments, but don't scale. There are enterprise options, which then would typically synchronize or interlink with an underlying enterprise platform, which then provides you possibly further capabilities. It really depends on what you need from your environment. So again, we need to think about the applications that are there. We then need to think about the network plugin that we're going to be using. Most deployments, if not all, typically define you to have to select the correct network plugin at the build of your Kubernetes cluster. So let's say today you build your Kubernetes cluster and you bootstrap Flannel as the underlying network, and then you want to go off and use one of the enterprise options so that you can interweave it with your physical networking environment. You're typically going to have to redeploy your Kubernetes clusters to achieve that. Once we've got over that hurdle of selecting our network plugins, and maybe we're going to use something that still works inside the Kubernetes cluster, maybe Calico or Andrea, which are both high performance, out of the box options to install. They have their own different nuances in terms of feature set. We need to think about how our pods communicate. So how do our pods communicate within a namespace? Do we potentially have pods that need to communicate between namespaces? And then thinking about how we actually access our pods, especially the ones that serve things like websites and application connectivity from outside of the Kubernetes cluster. So do we need to think about setting up ingress? So that's where we have a load balanced IP address, and then we do resolution on the domain name. And depending on what the suffix or prefix is of that domain name, then routes it to the right namespace and the right pod. So typically for an ingress, if you want something that's fully featured, you're going to be looking at implementing an enterprise-based solution. Or maybe you just need basic load balancing, where you've got a pool of IP addresses, they're tied to a load balance service, and that service is just configured to round robin across a number of pods that run your Nginx web front end, for example. From a storage access layer, we've already talked a little bit about this from Bart's question. Are we using the underlying vSphere storage? If we are, then that's great. It's passed through into the virtual machines at the ESXi layer from within the hypervisor, which is fantastic. However, I've gone one click too many there on my animations. However, if we're maybe using NFS, that's also a reasonable solution, but then we're going through the hypervisor onto the network, and then we're going across the network itself. So how many hops? The hops could be between ESXi servers when we're thinking about pod-to-pod communication, but also from the ESXi servers to then speak to the your NFS-based storage as well. Do you need to set certain MTU parameters for better performance, for tweaking? So, for example, the Antrea-based CNI understands the ability and capability to alter and modify the MTU. This is especially important if you're going to use any tunneling technologies inside of your clusters to tunnel to other clusters as well. So you may have come across in the community something called Inlets Pro. Inlets is a way to create a VPN connection between clusters or from your home to a cluster running in Azure, for example, so that you can work on stuff without exposing it. But it's going to tunnel that communication. It encrypts it. It adds an overhead to that. Increasing your MTU may be a way to increase the performance there, but you can only do that with the right networking plugins. Again, today from VMware, even with our own Kubernetes offerings, we have a number of plugins and network options available. So pod-to-pod networking, we'd use something like Antrea Calico. Our enterprise software-defined networking stack is called NSXT. We can use that as well. But when we go down that list to look at things like load balancing for management interfaces and pods, we can use our own enterprise load balancing, or we can use HA proxy. If we're deploying into a multi-cloud environment, such as AWS or Azure, then we would use their native load balancing services as well. So the other thing to be aware of is you may have to select your CNI at a pod-to-pod networking layer, but when you want to offer up these additional services such as ingress and load balancing, you may actually just be constrained to the platform that you've deployed upon as well. So we've kind of really touched on some design decisions already.
Sorry, real quick. Someone asked, could you explain a little bit more about load balancing of pods?
Yeah, no problem. So let's go back to this diagram here. So with the load balancing of the pods, the first thing that you're going to have to do is you're going to have to choose what the hell is actually offering the load balancing service. Is this going to be another application running inside my Kubernetes environment? So for example, Metal LB is a great load balancer, which is free to use. I use it a lot in my demo environment. But it runs inside my Kubernetes cluster. So all of my network traffic, before it gets load balanced my application, is going into my Kubernetes cluster to hit a container, and then that container defines where else it goes. Alternatively, I could use an external enterprise. So I could use NSX Advanced Load Balancer from VMware, for example. That infrastructure is going to be external to my Kubernetes cluster, but has an integration inside of Kubernetes so that when we create a service type of load balancer, so that's a configuration, it then Kubernetes will know to call off through the admission controller to the external load balancing services to create the virtual IP address and services so that it can understand how to route that. Then in the future, when I hit my external IP address, which is on my physical load balancer, it's going to send it back through into my Kubernetes environment. But with that integration there, it's going to understand which pods are relevant to the service that's being created and how to load balance them to them. So these pods could be ephemeral. So how do we get a list of which pods are available, what their internal cluster IPs are when they change, and which node that they're running on to route that traffic through as well? So hopefully that answers a little bit more around the question there.
I think we're good. Yep, crack on.
Perfect. And this is great. I love questions like this. Thank you very much for making this session interactive. Okay, so because I don't want to kill you with slideshows and too much, information, I have dumped it all onto one slide with less diagrams. But really, from a design point of view, before you even get to the point of installing Kubernetes and testing it in the lab, this is a detailed list that I came up with of kind of areas that we need to think about and discuss and, speak with our application owners and speak with our platform owners before we even get to that point of saying, hey, let's use Kubernetes, let's deploy it, let's get an application there. So the first thing is, let's look at, if you're going to use a virtualization layer, what do we think from a design and architecture point of view? Well, fundamentally, it's just like we've been designing virtualization for many years now. Fundamentals still the same because the Kubernetes is virtual machines sat on top of it. We need to think about the underlying configuration from a hardware point of view. So the resources, are we going to maximize the CPU to memory channels on the bus because we need to put high performance in-memory databases running inside of Kubernetes on this platform, or potentially side by side on the virtualization layer? What CPUs are we going to use? Have you got expandability inside of those hosts if we need to add more resources in rather than adding additional hosts? What's the storage read and write output from those hosts? Which HBAs are you going to be using? Do you have to use a multipathing plugin? Is multipathing supported? And if so, what options for multipath are available? Is it most used path? Is it least active path? Is it round robin? And can you tweak the settings for that for best performance? So very simply, does your storage vendor have a guide on how best to implement their storage with Kubernetes, for example? From a networking layer, what NICs are you using? Is there certain firmware or driver versions that need to be used? Do you want to have separate virtualization switches inside of the host that utilize a separate networking card dedicated to the Kubernetes traffic from those Kubernetes node VMs? And then finally, we come back to this idea of the cluster usage. Are we going to be dedicating our cluster to Kubernetes, or are we going to be multitasking it, using it with virtual machines that run our HR apps, our database apps, and so forth? If so, that means it's going to have an impact on the performance and the maximum that we can drive there. But also, you may have to optimize your cluster with certain settings for other applications outside of Kubernetes. Does that have a knock-on effect? Inside the Kubernetes cluster itself, think about the virtual machine resources. Are we going to have 3 compute nodes full of memory, full of CPU, and we try to run as many pods on there as possible? Well, there is a maximum number of pods that you can run inside a Kubernetes node, so you will have to scale out at some point. Because running virtual machines, check NUMA. So this is the alignment of the virtual allocation of memory and CPU to the physical host itself. If it's misaligned and got to go across memory banks, for example, then it can have a knock-on effect to high performance computing as well. And there's some fantastic articles out there from VMware, from other people talking about NUMA and about how to best design for that with your virtual machines and host design. Those same principles apply when running Kubernetes in virtualizations as well. And then finally, the anti-affinity rules. How do we keep those nodes away from one another in case something does happen inside of that virtualization cluster? Next, we think about the application layer. So how actually will we deploy our application? Are we using an automation system to deploy it? Is someone going to use Terraform as a plugin, for example, through its Kubernetes provider? Are we just going to drop YAML files onto there? We're going to use Helm to manage it. If so, that's very important, because then that system may or may not make decisions on how it deploys and the scale of that application to begin with, or its underlying configuration that needs to be changed as well. You can have more control using an automation system. If it's someone sat there doing it from their laptop, then they need to have a process of steps to go through to ensure that they've optimized that application before they deploy it. Are you going to let the system itself decide on how to manage the resources? So inside the Kubernetes, where to place pods? Are you going to set admission controllers to stop certain applications with certain tags being placed on certain nodes? Do you have certain environments which are configured for maybe PCI compliance, which therefore work slightly differently in the cluster to the other parts of the cluster, and applications need to sit only in PCI-based environments? Will you decide to set resource limits inside of the pod configurations and containers so that they don't run away if they have a memory leak or they get attacked or DDoS or generally have a problem and take up all the resources of the Kubernetes cluster itself? And then finally, I think it just talks about that, but will we use selectors for that placement logic of the pods and containers in the environment as well? And then future planning. How will we scale the environment? How are we going to scale an application? Are we going to use a horizontal pod auto scaler? So we do that based on percentage of CPU or requests coming in, or maybe some custom logic using Grafana and Prometheus. Or are we going to do this manually? Does someone go, hey, my website's running slow today. Maybe I need to add another front end and upscale the pods by, from 3 to 6. Once we've kind of scaled up our application, at what point do we think about, okay, I now need to scale the size of my cluster? So I could scale up, I could increase my virtual machine resources because I've not maxed it out, or because I may be hitting pod limits on per node, do I need to scale out? Do I need to increase the number of virtual machines in my Kubernetes cluster? If we're increasing the scaling up the virtual machine resources, we need to go back to things like NUMA and thinking about failure scenarios on that host, because there's more going on inside a single virtual machine, which can only sit on one host. If we're going to scale out the number of virtual machines, we need to think about the cluster usage. We need to think about that hardware configuration. When are we going to exhaust the underlying virtualization resources in that cluster? So this leads me quite nicely into the next area, which is monitoring. So we can monitor from the infrastructure up, so from the virtualization layer. We can do vRealized operations in a VMware environment. We have an integration there with Kubernetes, so you can go from an EXI host in your vSphere cluster, understand the storage that it's sat on, understand the host that it's sat on, and then understand that there's a Kubernetes cluster there and understand where the pods run inside that Kubernetes cluster. So we can say, hey, this set of pods is running quite poorly. We know it sits in this virtual machine. We now know that this virtual machine runs on this virtualization host, and we now know that this virtualization host is connected to these network and this storage, so that we can do infrastructure level. However, there's a limitation there. So it's not going to give us metrics from inside of our container itself. So if there's something going on, maybe in Tomcat service, we're not going to understand what's going on there, but we will see the details of the CPU usage and so forth of the pods and the containers. So then maybe we need to use something like Prometheus. So Prometheus is very, very extensible. It's a great tool. It's widely used out there in the Kubernetes world. You do need to use something else to pull those metrics to begin with. And we can get metrics from both the virtualization environment and the container environment. However, it's not going to be able to pull these together to display in the same dashboards and the same views and the same troubleshooting methods that you get from something like vRealized operations. Also with Prometheus, where are you actually going to deploy that? Do you deploy it inside of the Kubernetes cluster that you've been running? Or is this going to be external to the Kubernetes cluster? And if so, whereabouts will you place that? Typically in an enterprise environment, you're going to deploy that externally so it doesn't take up unnecessary resources where your applications run. From an application down point of view, so this is looking at the metrics, the uses, the SLAs, the KPIs, and aligning that maybe even to business goals, such as for our website, we need 99.9% availability. We can use a SaaS service like Tanzu Observability. This gives application level down visibility in granular detail, but it's less focused on the underlying platform which hosts the Kubernetes clusters for you. You can add that in again with additional plugins and so forth, but does it have the right layer of data for you? Is it showing you the data in the right context for you for the right teams who are going to be accessing these monitoring tools? Can you use that data, whether it's Tanzu Observability or another product that's out there in the market? Does it give you the data to monitor the platform and scale that platform as necessary? And do you then need to output that data elsewhere so that you can automatically scale in the future as well?
One thing that you mentioned about the access to those monitoring tools, in terms of the stakeholders when we're looking at monitoring, who really needs to be there, who is maybe a good to have, and who in an organization maybe doesn't need to be there to possibly cause confusion and maybe become a bottleneck?
Yeah, so straight away, if we're going to speak about this infrastructure up, then if we're running this in virtualization, your virtualization administration or operations team, they're going to be a stakeholder in this because they're providing you the underlying platform to host your Kubernetes cluster on for a start. So they need to understand how they can help monitor it. Because if you ring up and you say, hey, Dave, that pod's running really, really slow in Kubernetes again, and the Nginx website for our customers externally is just not working. The VI admin's going to sit there and they're going to go, okay, that's great. Where's the pod live? How do I troubleshoot that? If they have no knowledge and understanding of that, and that's a Kubernetes platform on there, how do they do that? So one of the things we worked on with our vRealize suite is we do a great job of monitoring and bringing you troubleshooting data so that you can analyze with root cause analysis the virtualization platform. The next step then is, okay, when Dave rings up, how does that VI admin get that insight? Say, oh, okay, Dave, you give me the pod name. I'm going to go off and find that and go, yeah, Dave, that pod runs on this node. That node's actually a virtual machine on this cluster, maybe running in San Jose. And actually, we can see in San Jose, we've got some storage problems out there at the minute that are being worked on. That may be causing you your problems inside of your little container there. So it's about getting these teams to work together, because those virtualization administrators typically aren't monitoring from an application point of view. At the same time, the other stakeholder, of course, is going to be the application user or the application creator or administrator. So they need that application down view. They need to know that, hey, I'm running 100 pods to front end my external website. And actually, at the moment, the load time or latency on our website is going up because pods are crashing for some reason. And I need to know what that impact is, because we're maintaining an SLA of 99.9%. So this is where Tanzu observability come into its own, because it can look and tell you about the availability of your website, about the microservices that make up your website, about can users access those different components of your website in a single page, relate that back to that SLA for you, and then start to alert when you breach that SLA. If your website front end is built up of 100 pods that are replicated, and 3 of them go offline, but your website still stays fully highly available, do you really care about that? Well, possibly the answer is no, because this is one of the whole ideas of microservices architecture and using Kubernetes. However, if another 20 go off and then the load times for the website go up, that's when you're interested as an application owner.
Very, very good. Thanks. No, just because I think sometimes it's one thing looking at the technology, but then also as these roles are, SRE is becoming more and more codified now. Just yesterday I had a very long conversation about DBRE, and, as a set of principles, as well as, a job title as DBAs are kind of shifting out of that. I think it's always interesting to think about, who are the folks that are going to have to be involved in making the decisions. And also what you were mentioning earlier, when we're talking about scaling, when we're talking about the day 1, day 2 operations, things of that nature, of thinking about one thing are the technologies, but then also who are the different people that are going to have to be involved there. Anyway, thank you.
No problem. So from a scale and a resource management point of view, we kind of already covered this a little bit. So the first thing is we can scale out our underlying virtualization platform. We just add more hardware to it. And we can scale it out by either adding more hardware, or we could upgrade the memory and the CPU that's in there. But sometimes that's a little bit hard because you've got to take the hardware offline to pull it out of the rack to do that. So usually it's easy to add more hardware. Then we can scale the actual resource alignments inside the virtualization platform itself. We can then use kubectl to scale deployments inside of our Kubernetes cluster. So here for this particular one, we're kind of thinking about it from a integrated VMware point of view. So if you use our opinionated Tanzu Kubernetes grid service that's deployed as part of our vSphere environment, you can actually just do kubectl scale, and it'll scale out the size of your cluster for you. Again, depending on the cloud provider that you're using, you can scale inside of the cluster at the control plane level. And then finally, you can scale resources inside of your namespace as well. So this way, using things like horizontal pod auto scalers to look at the usage of pods and scale them up and scale them down and keep a certain availability. You can use the manual kubectl command to scale up a deployment or a replica set or a number of pods as well. The options are endless. Some of these, obviously, here, we're looking at money, cost, change control to get this signed off. Here, we might just be looking at change control. This is something else you need to think of in your design. When you hit those upper limits, how are you going to overcome that, and how quickly can you do that? Okay, so we need more resources, but how? I think I jumped the gun a little bit there, remembering what's in my slide. So we have the horizontal pod autoscaler, so we scale up those number of pods. We also have a cluster autoscaler. So if pods fail to run in our cluster, fail to be scheduled, the service can look inside and then scale up and call off to our cloud provider and scale up and add an extra node. Now, that's brilliant to do that. But one, you need the available capacity inside of your virtualization platform or your cloud provider to do that, to add in the additional nodes. And then finally, a cluster autoscaler, for the ones that I researched and came up with, all of them required you to be configured at cluster deployment. So if you've got an existing Kubernetes cluster and you want to enable the cluster autoscaler feature, you have to redeploy your cluster from scratch. So you need to think about that. So you're probably going to deploy that side by side. That needs extra resources to do that for a moment in time. Then you've got to move your applications over onto that new cluster so you can deprecate your old cluster and delete it. And then, of course, there's the manual scaling of pods and cluster nodes, which is typically easier to do, but of course comes with all of those problems in the fact that it's manual. Okay, so we're getting to the end of the slides now, and we've not done too bad for time, despite my little mishap there having to answer the door to the Amazon driver. There are other retailers available you could buy and have your products delivered at your house to. So I kind of thought of all this and I wrote my slides down, and you can kind of see this is a bit more of a work in progress set of notes. But then I really started to go out to see what's available in terms of benchmarking tools. This, of course, is not a definitive list because Kubernetes space is growing every day. There's new tools, new updates released every second. You know, I can go to bed tonight and see 3 or 4 revisions of my demo application that I typically use be pushed by the day afterwards, depending if Michael from Caston's working on it or texting me overnight. But there's a number of open source projects, and I'm going to focus on the open source ones. There's 1 or 2 that you do have to pay for that I've added in here as well. But again, because as an enterprise, you're probably going to want enterprise tooling that you do pay for, because the idea here is you get support behind it. So you've got someone to ring, call, choke the throat of if you want to, if you have a problem with that particular tool set, for example, or you need assistance with it as well. When it's an open source project, typically you're opening a Git issue and waiting for someone to come back to you. Okay, so the first thing, how do we look at benchmarking our cluster management and our lifecycling? So one of the popular ones that we're going to go through, and it is a VMware open source tool, is called Kbench. So Kbench is a benchmark to, framework to benchmark the control and data plane aspects of Kubernetes infrastructure. So this is looking up at the rapid scaling up, scaling down, and stress testing of your control plane itself. How quickly will the API react to creating a number of pods? Is there a cliff that it falls apart when you send it a number of requests? Because again, if you're using an automation system to control your application deployment, that's very key. The more things that interact with your Kubernetes environment and the API, the slower that API is going to be able to respond. At what point does that become unusable? Storage point of view, I think Michael might have even gone through this in his talk from Caston a couple of weeks ago, Kubester, and that's actually one of my little demos today. It's a collection of tools to discover, validate, and evaluate your Kubernetes storage options. So this looks at the settings of the CSI provider. Does the CSI provider, from a data protection point of view, support snapshotting, for example? Then it also gives you the ability to do FIO tests, so you can test the IO and throughput performance of your underlying storage. Kbench has the ability to do that for you as well. Again, networking, and to be fair, networking was the hardest one that I found to find any benchmarking tools available. It's really hard. How do you benchmark pod-to-pod communication? How do you benchmark pod to external communication through the node, through the adapters on the node, through the API, through load balance services? There isn't many tools out there today, which makes it a bit harder to actually grasp. So Kbench has some tests in there to run for you, but also you're going to have to think about another way to kind of understand your networking. If you can't just run a pod and do an iPerf test from it to the outside world, which is what Kbench is doing for some of those tests, what else could you do? Well, next up, we need to think about the application build and load testing, because that will actually stress the networking and the storage performance as well. Now, application build and load testing, this is where we have a lot of open source options out there. So again, from VMware, we have Weathervane. It's an application level performance benchmark. It builds up an enterprise application infrastructure, and it basically stresses your cluster until it breaks and can no longer respond. So you can find those endpoints of where it's going to be. We've got K8's test suite, which is focused again on load testing. We've got KubeMonkey, based on the Chaos Monkey idea from Netflix. I'm sure we've all heard of that in the application space. Chaos Monkey or KubeMonkey goes around and randomly kills things in your environment and sees how your applications handle it. That's a brilliant way to stress test and load and all the rest of it of your environment. Randomly kill pods, take away storage and so forth, and see what happens to your application. We've got Powerful Seal, built upon Chaos Monkey's idea, and it takes it one step further, and it will also stress and kill or cordon or take offline cluster nodes as well. So what happens to your Kubernetes cluster and how does it react when a node goes offline and a number of pods were on there? And then finally,
real quick question with that too is because one thing when you're mentioning chaos engineering, things of that nature, you're talking about resiliency and robust systems. Yeah. When we talk about storage and databases, how does that play into that as well?
Yeah, so this is a really interesting one. So probably about when I started to work with Kubernetes 18 months ago, I was asking people about the whole database side of the world because I either seen lots of examples of people running database inside of Kubernetes, and that was really the only thing they were doing it for. Was it's easier to scale databases out in Kubernetes, and it's like, oh, that's quite a nice use case. And then I speak to a different set of people, and they'd be like, no. Databases and persistent data inside of Kubernetes is not what it's built for. Databases need their own instances and we leave them where they are. Now, 18 months later, I'm seeing more people being okay with running enterprise databases inside of Kubernetes because the features, the functions have got better. There's more use cases out there. People have time to play about with it more. When it comes to kind of resiliency, so again, you need to think about, okay, what does resilience actually mean? Does resiliency mean if my database pod goes offline, another pod replaces it and it accesses the same persistent data? That's the level of resiliency. That will affect the API and the cluster management and lifecycle to do that. The next resiliency piece is, well, I need to scale out my database, so I'm going to have multiple replicas. Am I going to run that inside of the same Kubernetes cluster, but scale it across my virtualization platform? Potentially, yes. That's going to stress the environment out because some of that data is going to be leaving those nodes, going across nodes to different storage options. The next piece of that to then build it up even further is distributed database systems. So distribution in the sense of I've deployed my MongoDB database, my replica nodes now live in another Kubernetes cluster in either a different virtualization cluster, potentially in a different data center. So, okay, are we doing log shipping? Are we doing transaction shipping across the network to achieve that? We have to think about that data path that it goes through. Are we going to do shared storage across those data centers so that we can use the same persistent data? Well, that means if the data becomes corrupt in one place, it's potentially going to be corrupt in both. Or are we going to keep two separate data formats that we then have to kind of rewrite those data transactions across that wire into the second MongoDB instance, then it writes it down to its own persistent volume? All of those will have different characteristics and different performance needs that they need to adhere to in that world. So that it becomes really, really complex quickly. Ironically, with the database piece, even though it's in Kubernetes, a lot of those thought processes are the same as when you just typically design database services. The one that gets a bit harder when it's in Kubernetes is that storage layer. So how do we get consistent storage that may or may not be stretched across two Kubernetes environments in completely different data centers? This is where maybe something like Portworx comes into play, what it can do with its data services for that piece.
Yep, very, very good. We also got a question. Hey, Dean, how do you find the sweet spot for a pod when scaling is required?
So this is a really hard one. It really depends on your application. So the first thing you need to do is you need to get some application-based metrics. So you can understand what actually is the fall-off rate of running my application, maybe just in a single pod. So if we're going to scale, if we have a website running through Nginx, and it's just a default HTTP page, it's got a counter on there that I can click. Let's do some testing against that load of that application, how many users can open up that page at any one time before that pod starts to show hitting the resource limit that I've put in place? Is it 10 users? So 10 connections to that pod. Is it 50? Is it 60? The next thing I need to do then is I need to say, okay, I want to then create 2 pods. How does that affect my users? Because not always do you end up with that thing saying, oh, well, I hit my limit of the resource limit with 10 users on. So if I create 2 pods and load balance, I should be able to get 20. It doesn't always quite work that way. And it's really that testing, that validation, and that feedback from those metrics that you're gathering from your application. And it starts off small and scale out, at reasonable pieces. I've seen it on the flip side, especially when I've been demo testing, which is I've done something really daft like, okay, let's put a pod autoscaler in there. And when I hit my resource limit, double the size of my pods, and then double it again, double it again, double it again. And actually what happens is my application was hitting maybe 90% utilization, and that extra one user loading up that website, they then were taking it over the 90% to maybe 91%. But all of a sudden, I've now got 10 more pods servicing that service. And actually, I didn't need 10 more pods. I might have just needed 1 more pod, because actually that extra 1 user was kind of the peak rate of users accessing the website at that moment in time. So this is definitely a consideration that you need to think about when you're using public cloud infrastructure, because all of them resources cost you as soon as you start to consume them. So the more resources you scale up to in AWS, for example, that bill goes up very quickly. And then what happens if you need to scale that down? If you've got those levels set wrong to scale down the size of your cluster, 20% of your traffic to that website could have dropped off, but the cluster hasn't scaled itself down because it's not hit that threshold limit to start deleting pods again. So you're going to be paying for pods that just aren't going to be used at the minute whatsoever, because the peak of your traffic ended hours ago.
Wow. Okay. Like you said, not an easy answer, but
Unfortunately, I don't have that easy answer for you. But again, there's a number of tools here for you to just throw into your Kubernetes environment, see how they react with those types of settings, and see what happens. Weather Vane is a fantastic one. So is KS Test Suite from that point of view, because they will carry on building pods based on your requirements and stress test that cluster and see what happens. Then add an autoscaler on there, see what happens if it tries to autoscale it.
And regarding the security compliance, because we recently had a conversation with somebody about, the National Security Administration's, advisory about how to harden how to harden Kubernetes, but more specifically thinking about the data and the storage aspects. Apart from misconfigurations, are there any things that really need to be taken into consideration when it comes to security?
Yeah, so a lot of people, whenever benchmarking any platform, always kind of forget about the security compliance piece. And I put it as security compliance here because it kind of resonates with everyone, but it could just be internal configuration compliance. Basically, you will have a baseline that you've defined upon as a company that you want to achieve, whether it's CIS benchmark, whether it's your own internal benchmarks. You need to understand when you start to enable those settings, how does that affect your performance? If you're using, for storage, for example, if you're using NFS storage and you turn off NFS version 1 and version 2 and only version 3 is available, typically version 3 is a lot faster, but it also brings into the mix authentication and encryption. So what happens when all of that's turned on? Does it affect the networking? Does certain things slow down? Does your actual application code, can that work correctly with those protocols in use by the storage if it's connecting directly? There is other things from the CIS benchmarks as well. So again, one of the first things you'll see if you run Kbench or Runecast, for example, Runecast being one that you would pay for out there, does more things than just CIS benchmarks in your platform. That's going to recommend, for example, to set resource limits on your pods. Now, it's a brilliant piece of advice and everyone should be doing that. But if you've not been doing that and then you just go off and then start setting resource limits left, right, and center on all of your applications, are you setting the right levels? What should your resources be? What data are you using to back up those settings that you're putting in place? If I go ahead and just put this on my demo app today and put in 100 megahertz as the maximum request limit for a pod, is that enough? Is it not enough? So again, you've got to take this security compliance, understand each of them, slowly introduce those changes, especially into an existing environment, and then go back through those testing validations that you've done before. So run the same benchmark tools again once you've implemented a number of those security features. Go back to your baseline. Did the application was it responding at 10 milliseconds previously? Is it now responding at 15 milliseconds? Is 15 milliseconds an acceptable response time? Or is it not? And if it's not, you then need to work back and figure out, okay, what change made that problem and how do I rectify that? There's been many occasions over the years, especially outside of Kubernetes, that I've gone into an environment, we've found some application that isn't working correctly from a performance point of view and just falls over. And when we finally get to the root cause analysis, it's because of some configuration change that someone's made, whether it's security compliance based or just internal, we think this is a best practice to achieve.
Perfect.
So I think we are just coming up on the hour at the moment, Bart, which means, unfortunately, I don't think we've got enough time for a demo in place. So what I'm going to do instead for everyone that's listening, I thank you for your time in joining me today. It's been an absolute pleasure to present on the Data on Kubernetes community. A couple of weeks ago, there was a session by my good friend Michael Cade from Caston. He showed off Kubester. Kubester has some pieces in there that uses what's called FIO tests. So that does IO tests against your storage for reads and writes, and you can specify your own settings for that. Go back, watch his video footage on that, because I was going to show some of that today anyway. But in your own Kubernetes environments, go back to those benchmarking tools that I've mentioned, download them. They're quite easy and accessible to use. Play around with them, have a test, change some of the settings yourself, have a go of it. It's all about learning and understanding. For those of you that are doing this in production or an enterprise environment, my recommendations are the same that they would be for traditional virtualization infrastructure. Test, validate, baseline, make the changes, test, validate, baseline. Go back through that process continuously. Even if you're not making changes in your Kubernetes environment once it's productionized and available, make sure you've got a check base in the future. So maybe 3 months down the line, you spend one of the days just going back, running maybe less intense performance tests on the environment, but also just so you can keep an eye on that baseline as well to make sure it's not drifting. If it's starting to drift, that could be a performance indicator in your environment that something's starting to go wrong. It might not be inside of Kubernetes itself, especially if you're sharing the virtualization platform with other applications. You might have a noise enabler that causes that problem. But essentially, everything for Kubernetes performance, design, and benchmarking comes back to the same thing. It's about sitting down and working out your baseline parameters, understanding your design fundamentals, then having the data and the metrics to back that up and be able to reference it in the future. Because ultimately, you're probably going to come back to this when it's a problem, when something's not performing right. So thank you very much, everyone, for your time today. Really appreciate the interactivity and the questions that have been asked. My name's been Dean Lewis. Thank you very much.
Dean, amazing. One thing, well, a couple of things really quickly. First of all, thanks so much for the amazing presentation. I don't think we've had a presentation that got so much into 1 hour. That was incredible. Really hammering this stuff down. But also, I think there's a lot of pressure and stress that people might get thinking about design, but also with freedom comes responsibility. And it's also other things that you mentioned there previously too, when we talk about SLOs, SLAs, SLIs, a lot of people to actually say, what are my objectives? What are my parameters, as you mentioned as well? And particularly in a role where, okay, we might talk about architecture, but really thinking about design, just the word itself doesn't sound like something that's being frequently used in these sorts of areas, but in reality it is. And so imagining how does this need to look? And once again, too, based on the problem I'm trying to solve and what people are willing to pay for, what kind of design is going to be necessary in order to provide the solutions that I think are giving value to my customers. Last thing though, can I get you to stop sharing your screen real quick?
Yeah, of course you can.
Perfect.
No.
We got a tradition in our community. So while you were speaking, we had our amazing graphic recorder, Anke, who created, can you see my screen?
That is brilliant.
Yeah, so we didn't get the Amazon delivery person, but we did get your dog and some nautical stuff in there with diving. So that got matched in there, as well as some of the topics that you touched on. Obviously, we would need probably about 10 to 15 drawings if we wanted to touch on all of them. But anyway, Really, really enjoyed it. Big shout out to Michael Cade for kind of putting us in touch and making this work. If, as you said as well too, for folks who want to see more, maybe the code, the demo side, you can definitely check out the live stream that we did with Michael. We'll put that in the description when we upload this to YouTube. And Dean, it was great to have you, and I'm pretty confident we'll be seeing each other again. So
yeah. Thank you very much for having me. Sorry, everyone, that I didn't get to the live demos today. Really apologize for that.
No, but it's because you were giving amazing answers to questions, so it's all good, man. No worries. Thanks, Dean. Take care.
Thank you very much. Bye now.
Cheers. Nice.